Hello everyone, welcome back. Today we have 2125 number of laser beams in a bank. It says here there's some anti-theft security devices which are activated inside a bank. So these are the devices, and we're given a zero index binary string array bank representing the floor plan of the bank, which is an n by n 2D matrix. Now, each one represents the row consisting of zeros and ones, where 0 means the cell is empty, while 1 means the cell has a security device. So this would be represented as 0, 1, 1, 0, 0, 1. There is one laser beam between any two security devices if both conditions are met. The first of the two is that they're both located on different rows. So this row and this row would be considered different rows. And the second condition is that for each row, there are no security devices in between the two rows, meaning there can be a beam between these two because this is empty, but there cannot be a beam between this device and this device because in between rows, we have a row containing security devices. So the beam can only go across one level. Um, Here, we see that they're very adjacent. So this is the previous row, this is the current row. We can see there can be a beam. However, in these two cases, there can only be beams because in the middle, there is no row containing any security devices. So essentially, this is our previous row and this is our current row. Okay, so the logic is actually pretty simple. And note that there are beams between any two devices. So from here, any two devices, from here, any two, each of these have lines between all of it. Okay, each one has lines to every other. Each one has lines to every other between the two rows. Okay, so let's try it out. We have the first example, which I pasted it here and then just drew out here so we can, mark it more easily. And we have the different rows. We'll say we only really care about two rows, which is the previous row and the current row, because the second condition is that there's no middle row that contains security devices. So we only care about two rows at one point. Okay? So what we can do is actually go through each row, and let's say we're keeping track of what's the total being, total or the results, which will start at 0, and we're keeping track of the previous row. Okay, so let's start. We're on the first row, and we can count the number of security devices in our current row. There are 3. There are 3 devices in the current row. Now, if we had a previous row, we would count the number of beams by taking the previous row count times the current row count. Previous count, previous count is 0. So 0 times 3 is 0. So nothing to do there. Okay, now our current row is here. We note that there's actually no devices whatsoever, so you know what? We need 2 rows that contain devices. This row doesn't contain any. We'll skip over this row and consider this our previous row still, and then we can move on. So now this is our current row. Our previous row is here. In this current row, we have 2 security devices. Okay, and then we can say, all right, how many beams are there between this current row and this previous row? We can just multiply the counts with each other. And we can see here, if we do, the current row times all of these guys, right? And this one too, all 3. This one too, all 3. Essentially, we get 6. And that's what we want. So the previous count is 3. And the current count is 2. 2 times 3 is 6. Add that to the total. We now have 6. All right. And because this current row does contain devices, now we can set the previous row to this current row. and move the current row to the next row. In this current row, we have one device, okay? And our previous row has two devices. So we just add 2 times 1, and we can draw it out here for reference. 2 times 1 is 2, added to the total, this becomes 8. And so if we see we have total 8 beams across the security devices, abiding by these two rules, where both rows need to be separate rows, and there can be no middle row that contains security devices of its own. All right, so let's code this out. Okay, so what we did was we had some number of total beams that we were tracking, which starts out at 0, and we were always concerned with 2 rows. The first one, previous row starting at 0, and then what we did was we iterated every binary string in bank. So for bun string in bank, we'll say the current row is whatever is the count of ones in that current row. So this row has 3 because at 0, 1, 1, 0, 0, 1, we're counting the ones, the ones. The current row has total 3 security devices. Previous row had 0. And we say if there is a row, like in this case, there would be no row, so we would be skipping over. But in the first instance, we do have a row. Then we add to total beams whatever is the previous row multiplied by whatever is the current row. So the security devices in the previous row multiplied by the security devices in the current row. At first, it's 0. In the second iteration, we'll skip over this guy because the current row count will be 0, so we'll never hit this condition. Once we reach this row, our previous row will have 3, our current row will have 2, and we'll be adding 6, which is 3 times 2, 2 total beams. So let's do that. And then we need to set the previous row because the current row is valid and we're done adding our current row's count. Let's set the previous row to our current row, which is valid. And then at the end, we can straight return the total beams. And that's it. Oops, hold on. Total beams. That's not right. Total beams. Okay, we'll give that a few seconds. Yeah, so the main idea is we're going through each string in bank and we're just tabulating, keeping track of the previous valid row, valid being it has the security devices, and if not, we discard it. And if the current row also has security devices, then we multiply the previous row's devices with the current row's devices, and after adding that to total beams, we reset previous row to current row. Now, if the current row has no security devices, as in if the binary string's count of ones returns 0, we'll skip this code block altogether. And at the end, we return total beams. Give that a run, and a submit. And there you have it. This one does run in linear time with constant space. And pretty efficient. Once again, that's 2125 number of laser beams in a bank. Thanks so much. Happy coding. See you next time.